Hello and welcome to another exciting chemistry uh, segment. So today we're starting the series on energetics of chemical reactions. This is your host, Mr. Monsai, chemistry tutor. So energetics of reactions, we're looking at two words, energy and reactions. So basically we are focusing on the energy that is associated with chemical reactions. For a chemical reaction to transpire, there is energy that is involved. It's either the energy is gained or the energy is lost. So when you talk about energetics of reactions, it comes down to us focusing on the energy that is involved in a chemical reaction. So the learning objectives for today, we're basically going to focus on just two objectives. We're going to describe, number one, we're going to describe what an endothermic and exothermic reactions are. Then we're going to determine which reaction is endothermic and which reaction is exothermic. So for today, we're just going to focus on basically those two objectives. So to start with, uh, let me go down into those two details. So we're going to understand what is an exothermic and what is an endothermic reaction. So if we recall, at some point we looked at an endothermic and an exothermic reaction. And by then we're looking at the changes of states of matter. When matter is changing from one state to another, those physical processes, melting, freezing, sublimation, deposition, they were classified into two categories, an exothermic process or an endothermic process. So what is an exothermic process or what is an exothermic reaction? So the word exothermic comes with two, it's a combination of two words. There's exo and there is thermic. So exo means outside or outside. Then thermic means heat. So basically what this means is that it's a process that involves the release of energy. It's a process that involves the release of energy. So the word exothermic describes a process that releases energy in the form of heat. So heat is liberated, uh, energy is liberated in the form of heat. Exothermic reaction usually feel hot because they release heat to the surrounding. So in an exothermic reaction, we tend to feel the heat from outside. Then the opposite is what is known as an endothermic reaction. So an endothermic reaction, again, we're going to look at the two words that are involved. There is endo and then there is thermic. So endo, it's inside. Then thermic is the heat. So by definition, we say it's a process where heat energy is absorbed, that is inside. So heat energy is absorbed. They're saying an endothermic reaction refers to processes that absorbs energy, and this energy is in form of heat from the surrounding. So the energy is absorbed from the surrounding into the system. So endothermic reaction, the surrounding feels cold. The surrounding feels cold. We're not going to go into the bond breaking and the bond formation. So basically that is the meaning of endothermic and exothermic. So maybe just to make it more clear, let me use the whiteboard and share something. Okay, so let me do this. So we said exo is outside, then thermic is something to do with heat. Then the opposite is endo, which we said it's inside. Allow me to extend this. So it's inside. Where are you? Inside. And then it comes down to heat. So heat is the thermic. Heat is the thermic. Then we said exothermic deals with the release of energy. The release of energy. Release of energy. Energy. Then endo means absorb. That is energy. So energy is absorbed. So that is just the basic understanding that we need to get. Exo energy is released. Endothermic energy is absorbed. Now they have talked about two important words maybe I need to they have talked about the system. So allow me to make this as the system. So we say we have a system. Okay, let me just use the freehand. So we have what is known as the system. We have what is known as the system. And then what is outside the system is the surrounding. What is outside the system is the surrounding. So we have the surrounding outside. We have the surrounding outside. The surrounding is outside. So when we're talking about an exothermic reaction, they are saying heat is moving, is being released. Where is it coming from? So heat is being removed, it's being released from the system, and it's going to the surrounding. Heat is moving from the system and it's going to the surrounding. Therefore, the surrounding is becoming hot. That is why they mention that when it's an exothermic reaction, you feel the heat, you feel hot. The best example is you set up a brazier. The moment you set up a brazier and it's a cold season, you begin to warm yourself using that brazier. So the heat that you'll be receiving, the brazier becomes the system, and then it's giving out the heat, and you as a surrounding, you begin to feel the warmth. So that is an example of an exothermic reaction. Now the opposite is an endo. The opposite is an endothermic. What happens in an endothermic? So you have a system and the surrounding. But in this case, the surrounding is now giving heat to the system, and the system is absorbing, the system is absorbing the heat. So that is the difference. In an exothermic, the system is liberating the energy, therefore the surrounding is becoming cold. In an endothermic, the surrounding is giving the heat to the system, and the system is becoming hot, leaving the surrounding cold. So in an exothermic reaction, you're going to notice that the surrounding becomes cold. So if it happens that you are the surrounding, you're going to feel cold in an endothermic reaction. Let's look at what is being explained. Allow me to use this. Exactly. So allow me to get back to the notes. So when we look at examples of exothermic and endothermic, it will take us back to the physical processes that are involved in the change of state of matter. So we're going to talk about formation of ice. When you're forming ice, that is the freezing process. The freezing process is an example of an exothermic. Condensation of rain, a candle burning, the mixing of water and strong acids, the combining of atoms, the neutralization reactions. So basically those are examples of endothermic and exothermic. But it's very difficult for you to tell just by looking at those examples. Therefore, you can conduct a practical and be able to tell which reaction is endothermic and which reaction is exothermic. And that is what we are going to do to identify which reaction is exothermic and which reaction is endothermic. Remember, we said exothermic heat is released, endothermic heat is absorbed. So we're going to investigate what happens when we get potassium, or could be barium nitrate, it could be ammonium nitrate. When you dissolve it in water, are we able to tell the nature of the reaction? When we get sodium hydroxide, are we able to tell the nature of the reaction? So that is what I'm going to demonstrate in just a few minutes. So allow me to just demonstrate these two experiments. So in the first experiment, we're going to use a nitrate, and then in the second experiment, we're going to use sodium hydroxide, just to see the difference between the two, how we can distinguish between an exothermic and an endothermic reaction. So what I have here is barium nitrate. So when we get barium nitrate, we add just a few of it in the beaker. Just crush barium nitrate. Then we add water. Add water to it. So we're going to just shake so that we have a uniform solution. Now, as you are shaking, when you hold this beaker containing barium nitrate, you're going to realize that you feel cold. So you're going to feel cold. When you feel cold, in this case, the palm is the surrounding. The palm is the surrounding. And what is happening inside there, the chemical reaction itself is a system. So when you hold the beaker, you're going to feel cold. So by feeling cold, it means that you're losing heat. Heat is going into the system. Remember, your palm is the surrounding. So the palm is feeling cold. Therefore, the heat is leaving your body and it's joining the system. Therefore, whenever you feel cold, it means that that reaction is an endothermic. So an endothermic reaction absorbs the heat from the surrounding. So you are the surrounding and you're going to feel cold. So whenever you feel cold, it means that that reaction is an endothermic reaction. The alternative way you can prove that this is an endothermic reaction, what you can do is you can use a thermometer. So you can use a thermometer. How do you use a thermometer? So you get a thermometer, the tip of it is submerged in the water, then you get your initial reading. So looking at the thermometer, my initial reading is at 23. My initial reading is at 23. And then you add the barium nitrate to this water. So meaning we get the thermometer, we put it in the container containing barium nitrate. So I am observing a decrease in temperature. So my temperature is decreasing. It has gone to 21. The temperature has gone to 21. So whenever you notice a decrease in temperature, I don't know how visible. Whenever you notice a decrease in temperature, it means that that is an endothermic reaction. So the system absorbs the heat from the surrounding. So the thermometer in this case is the surrounding. So when you put it there, you notice that the temperature will decrease. So it's either you use your palms to feel cold, that is an endothermic reaction. You use a thermometer, the temperature decreases, then that is an endothermic reaction. Now let's look at an exothermic reaction. What happens in an exothermic reaction? So exothermic reaction, we're going to use sodium hydroxide. We're going to use sodium hydroxide. The sodium hydroxide is put in a beaker. So we get the pellets of sodium hydroxide, put in a beaker. Put in the beaker. So I have those pellets of sodium hydroxide. So I can just stir. So in this case, I just shake because I don't have a stirring rod. So I can just shake so that it can dissolve in the water. So as you hold the beaker, you're going to feel warm. When you hold the beaker, as you are shaking, you're going to feel warm. So when you feel warm, it means that the system, which is the reaction, is releasing the energy to the surrounding. And remember, your palms are part of the surrounding. So when you hold this beaker and you feel hot or you feel warm, depending on the quantity of sodium hydroxide which has been put. So I'm feeling warm right now because this is an exothermic. Heat is being released to the surrounding. Alternatively, you can use a thermometer. So you get the thermometer, you take the initial reading in the water. So my reading at the moment is 22.0 degrees. So when I get this, I put it in the beaker containing sodium hydroxide. You will notice you're going to notice some increase. You know, if we're able to see that, yeah, we're able to notice some increase. It's going all the way up to 30. Yeah, I'm sure we can see the graduation moving. So whenever the temperature increases, it means that the reaction is exothermic. It means that the reaction is exothermic. So basically that is how you can differentiate an endothermic and an exothermic practically. So when the temperature increases, that is an exothermic reaction. When the temperature decreases, that is an endothermic reaction. When you feel warm in the palms, that is an exothermic reaction. When you feel cold, that is an endothermic reaction. So basically that is what these experiments we're looking at are all about. So ammonium nitrate is dissolved in water, and then when you're hot, you're going to feel cold. You're going to feel cold. Alternatively, you can use a thermometer as mentioned. Then you can record the initial temperature of water. So in our case, the initial temperature of water in an endothermic reaction was 23 degrees Celsius. When we put in the solution, which is the barium nitrate, it came down to 21. So when the temperature goes down, that is an example of an endothermic reaction. When we used sodium hydroxide, so this is just an explanation. This explains why your palm feels cold. So you're going to feel cold. You're going to feel cold because you are the surrounding and you are losing the heat and it is going in the system. So that is basically just the explanations as to why you're feeling how you're feeling in the palms. Then look at another reaction using sodium hydroxide. So this is the one I was demonstrating. So for us, the temperature here was 22 initially. The temperature of water was 22. When we added, it rose to 30 plus. It rose to 30 plus. So when the temperature increases, it's an exothermic reaction. So basically, there's our explanation. So when sodium hydroxide dissolves in water, heat energy is released to the surrounding. That is to the thermometer, the beaker, the air around, and to your palms. This is the reason why the palm feels warm and the temperature of the solution is higher. That is basically what we observed. So that is just another illustration. When the temperature at room temperature, we are having a normal temperature somewhere here. When the temperature goes down, it means that the B is an endothermic reaction. When the temperature goes beyond the room temperature, the C is an exothermic reaction. So those are more analogies as to why it's endothermic and exothermic. So that was just a basic introduction of endothermic and exothermic. So we'll continue this series until we finish the entire topic. So this has been your host, Mr. Monsa. Until we meet next time. Bye-bye.